So when we're talking about a cell, we're talking about a nerve cell right now, right? Because we're talking neuromuscular junctions.
Yeah.
Neuro meaning nerve, muscular meaning muscle. So usually we've been drawing it like this, where we've got potassium on the inside, sodium on the outside. What we can be drawing now is just sodium on the inside, or potassium on the inside, sodium on the outside. Does that make sense? So, we're going to go over summation first. Is that cool? Does everybody need that?
Yes.
Okay. So when we see potassium going into the cell, we can say it's inhibitory, right? And I totally spelled that wrong. We'll just go with it. And we see sodium going into the cell, it's going to be excitatory. Why is that?
When sodium goes into the cell, it
Depolarizes the cell, right? We're still talking action potentials. This is still action potentials. So when we see a cell, and it goes up like this, the cell's becoming excited. It's depolarizing. It's hitting threshold. Action potential's occurring. It's getting excited. If that's not happening, and say it goes downward, is it getting excited? It's getting inhibited, right? It's hyperpolarizing. It's further from causing an action. It's just becoming more negative. You guys following that?
So the hyperpolarizing. Right?
Hyperpolarizing, yeah. So we're talking summation. We're talking about the different ways that these guys compete. So there's two different types of summation. There's temporal summation. When we're talking temporal, we're talking time and frequency. For example, if sodium's rushing into the cell, I'm just spitting out random numbers. 200 a second, that's the frequency, right? And then we have spatial summation. What does spatial summation include?
coming from different parts of the neuron.
Yeah.
Yeah.
So it's going to be
different.
Different areas.
like the number of receptors
That's right.
and location.
So it's not coming from different neurons, right? Like the way I drew it in class, it looked like it was coming from like different, or I guess different, like other axons. Does that make sense? From like other.
They will,
Oh,
in a way. Yeah. So you have two different kinds of synapses. You have chemical and you have electrical. Electrical is going to be in your heart and in your soft tissues. But the chemical ones are the ones we were talking about right now with like your muscles that you move and you control. And so what you're really going to have is something like, you'll have all these dendrites coming off and you'll have more nerves coming down like that. And so as these are triggered, they're going to trigger this one and that one's going to trigger something else. And then it's going to hit your muscle.
So like those two coming to that one is spatial summation?
When we're talking summation, we're going to talk mostly what's going on right here.
Okay.
That's going to be convergent. You guys got the word convergent, divergent?
Yeah.
Yeah, because they're converging, they're coming together. It could be a convergent pathway.
Okay.
Whereas if this was breaking off into two down here, it'd be a divergent pathway, right? And I think there's circulatory. Is that what it is?
Yeah.
Where it circles back around. Kind of like a reflex. Are you guys doing reflexes yet?
Like
Golgi tendon? No? Okay, never mind. You'll hear about it soon. That's the fun stuff. Okay. So, number of receptors and locations. So we could talk about it on the soma. If you have a whole bunch of these receptors, and then you have these other receptors, we can say that there's a good chance it's going to win by spatial summation because there's a whole bunch of channels for them to come through, right? And if we have the axon helix, we're really concerned about this part of the axon helix because there's a lot of voltage sodium channels. And if these guys get hit by an action potential, there's going to be tons of sodium rushing in to cause the electrical current to travel down here. So that's really what we're aiming for. So these guys can all rush in as much as they want, but unless they actually hit the axon helix, we're not going to see that action potential occur. That makes sense? And so we could also say it's spatial summation if, say we've got all these different channels here, but we put a bunch of these channels in right next to the axon helix, because they could drop in sodium really easily, and it's going to beat out all the potassium that's getting leaked in over here. That makes sense? They're just closer to it, so they could get to it quicker, and they'll beat them to it. Okay. Any questions with spatial summation? Higher number of receptors, so good chance of more flowing in, and then they're put in a good location. Temporal summation, we're just going to simplify this. We're just going to draw two different receptors up here. One's sodium, we'll say this one's sodium, this one's potassium. If sodium's rushing in at 200 a second, and potassium's rushing in at 300 a second, it's more likely that potassium's going to beat sodium, right? 100 more per second. You just have a bigger army coming in. Does that make sense? Mm-hmm. And so if they beat it to here, it's going to be inhibited because it's potassium. It's going to hyperpolarize the cell. Make sense?
Yeah.
Okay. I don't remember. Maybe it did. Okay. I'm just trying to understand.
What's your question?
That's good. No, the speed, I got it now.
Okay.
I was just
Yeah, it's
trying to
just
remember
how much it's letting in at a time. So that could be controlled by really the concentration gradient on the outside, right?
Yeah.
So if you have hypernatremia, maybe it's going to be increased to 400 because you have more sodium wanting to rush into a lower gradient. That makes sense?
Good.
Like, would they ask something like that on the test? Yeah.
They'll ask something like, potassium is rushing in at whatever per second versus sodium. And it beats it to the axon helix. Did it win by spatial summation or temporal summation?
And that one is?
It'd be temporal summation, right? Or they'll say, there's a lot of sodium receptors right next to the axon helix. And there's actually a lot more just all around than there are potassium receptors throughout the soma. Temporal or spatial? Spatial, right? Yeah, so that's pretty much it. Both of them are taking place at the same time, so they're both having an effect because time and frequency is occurring and location.